Imagine holding your smartphone right now. You tap an app, ask an artificial intelligence to, generate a video or write some complex code, and literally a second later, the answer just beams down from the cloud.
Right, it feels completely weightless.
Exactly. Invisible. It's like pure magic just hovering somewhere in the ether.
And, I mean, we spent decades building that exact illusion, right? The tech industry has really trained us to view the digital world as this separate realm, something completely untethered from the messy realities of the physical world.
Well, today we are going to completely shatter that illusion for you. We're jumping into a deep dive on Thursday's Daily Tech Reader, specifically their 4 p.m. news brief dated July 16th, 2026. And the underlying theme is just undeniable.
Yeah, it really is.
When you look at the raw data in this brief, from global supply chains to macroeconomic indicators, you realize the digital world is violently colliding with extreme weather, global conflicts, and honestly, just raw physical limits.
It forces a complete perspective shift. You really can't understand the future of software or AI without looking at the concrete, the steel, and the human labor required to keep those servers running.
Right, which brings us to the biggest story in today's brief. And we aren't starting with a software update.
No, definitely not.
We are looking at a colossal, earth-moving construction project in the Arizona desert. TSMC, that's the Taiwan Semiconductor Manufacturing Company, is pouring an additional $100 billion into their Arizona facilities.
Which is just a staggering number.
It really is. I mean, that pushes their total planned American investment to $265 billion. That is not just building a factory. That is like the GDP of a small country.
To put $265 billion in perspective, we are talking about funding on the scale of the Apollo program, or, the creation of the interstate highway system.
Wow.
Yeah. They are creating sprawling, miles-long advanced fabrication and packaging facilities. And it's driven entirely by the sheer insatiable computing power required by modern artificial intelligence.
Okay, let's unpack this. Because it's like we thought we were just building this ethereal brain in the cloud, but the reality is we're building the heaviest, most resource-intensive industrial project of the century.
Exactly.
And it's clearly paying off for them. TSMC just reported a record quarterly profit of roughly $22 billion.
Yeah.
But what stands out to me in the source is that a massive 2/3 of that revenue is now coming directly from high-performance computing.
Right, and high-performance computing, or HPC, is essentially the engine room of AI.
Okay.
It's the incredibly dense server architecture that trains those massive language models you interact with every day. But hitting those performance levels requires a fundamental shift in how microchips are actually built.
Because we're hitting a wall with the old way.
Exactly. For decades, we relied on standard wafer fabrication, which is just printing smaller and smaller transistors onto silicon. But we are hitting the literal boundaries of physics. You can only shrink a transistor down so far before the electrons start behaving unpredictably.
So instead of trying to make a single monolithic superchip, the brief highlights this major shift toward what they call advanced packaging.
Yeah, which is a great term for it.
Think of it like building a corporate executive team. Rather than trying to engineer one single massive chip that handles all the math, the graphics, and the memory all at once.
Which is almost impossible now.
Right. Instead, you manufacture specialized, smaller chips, often called chiplets. Then you intricately stack them vertically and horizontally, wiring them together so densely that they function as one unified, incredibly powerful brain.
But that dense stacking solves the space problem while introducing a massive engineering nightmare.
Heat.
Heat and communication latency, yes.
Yeah.
If you push standard electrical signals through copper wires in a space that microscopic, the resistance of those electrons bumping into each other generates terrifying amounts of heat.
And then it slows the whole computing process down.
Exactly. That's why the brief specifically points out the integration of silicon photonics.
Okay, this detail completely blew my mind when I read it. We're moving away from using electricity to transmit data inside the chip and moving toward light.
It's incredible.
Silicon photonics means engineers are essentially embedding microscopic lasers directly into the semiconductor.
Right, because photons don't encounter the same physical resistance as electrons. They don't generate that same friction.
And they move data at literal light speed. I mean, we are shooting lasers inside computer chips just to keep up with AI demand. It sounds like pure science fiction.
It does. But running these photonic chips at the scale of a commercial data center requires a brutal amount of physical resources. And this brings us to what the source calls industrial permanence.
Right.
AI is no longer just a line item on a tech company's software budget. To power and cool these millions of chips, the data centers require astronomical amounts of electricity and millions of gallons of water.
Which is crazy to think about.
It is. What's fascinating here is that AI is now dictating long-term regional planning and forcing massive utility expansion across the country.
And the physical utility grids are practically buckling under the pressure. The brief points out that severe grid equipment shortages are actively holding data center construction back.
Yeah, that's a massive bottleneck right now.
You can have all the funding in the world for these AI chips, but if you cannot source the high-voltage transformers to connect your facility to the regional power grid, and those transformers apparently take years to custom build, you are just left with a multi-billion-dollar empty warehouse.
And tech companies are painfully aware of this bottleneck. They are stepping completely outside their software expertise and directly funding the power infrastructure.
Wait, really? The tech companies themselves?
Yes, utilities are actually demanding it, frankly, to protect their everyday residential customers from absorbing the massive rate hikes these data centers would otherwise trigger.
Wow. But, I mean, you can't just order a new regional power grid with a click of a button. You have to physically build it. You need pipe fitters to install those massive data center cooling systems. You need high-voltage electricians, structural welders, concrete layers. And that immense physical labor requirement leads us directly into the paradox of the current U.S. economy.
Right, because we are seeing businesses consistently sounding the alarm about a severe shortage of these skilled tradespeople. The labor market to build physical infrastructure is incredibly tight.
So let's unpack the economic numbers in the brief, because on the surface, they look phenomenal.
They really do.
Weekly unemployment claims just hit a 10-week low of 208,000. Retail sales are ticking up by 0.2%. Core retail sales, which strips out the volatile categories, rose 0.5%. Economists are even raising their second quarter growth estimates to 2.4%.
Which sounds like a booming economy.
Exactly. If you just read those headlines, you would assume we are in the middle of a golden age. Nobody's getting fired, growth is solid, people are shopping. So what does this all mean? Why is the economic narrative in the source so cautious? Isn't this just a boom?
Well, the hesitation exists because those aggregate numbers mask a profoundly two-track economy.
Okay, what do you mean by two-track?
If you dig into that core retail sales jump, that 0.5% increase, the brief specifies it as being driven heavily by automobile and online purchases.
Gotcha.
Those are discretionary expenses fueled almost entirely by higher income households, people who are sitting on comfortable financial cushions and stock market gains.
Meanwhile, the brief points out that lower income households are facing completely different realities. Their financial margins are thinner than ever due to depleted savings and a fresh spike in gasoline prices.
Exactly.
So we have this paradoxical situation where the push for a futuristic, supposedly labor-saving digital economy is actually triggering a massive boom for physical labor.
Right. The irony is incredible.
If you are a skilled electrician or a welder right now, you can basically write your own ticket. But if you are an everyday consumer carrying debt, you are walking a very fragile tightrope.
And ironically, the strong macroeconomic data actually makes things harder for that everyday consumer. Because unemployment is low and overall spending is resilient, the financial markets see what the brief calls a slow hiring, slow firing environment.
Right.
In response to that resilience, Treasury yields are staying elevated.
Let's pause on Treasury yields for a second just to explain the mechanics. Treasury yields essentially represent the return investors get for loaning money to the U.S. government. And they set the floor for all borrowing costs across the entire economy.
Exactly.
Because the broader economy looks strong, investors expect the Federal Reserve will not feel any panic to step in and cut interest rates in July. The Fed doesn't need to stimulate a crashing economy.
Right, they don't want to overstimulate.
But because that baseline rate stays high, your credit card rates stay high, your auto loan rates stay high, and your mortgage rates stay high.
And if you have significant capital, those high interest rates are great. You are making solid returns on your investments. But if you are a lower income earner relying on credit cards to bridge the gap at the grocery store, that high interest rate is punitive. The economy is technically dodging a recession, but that very resilience is keeping borrowing costs punishingly high for the working class.
Add the rising price of gasoline on top of those borrowing costs, and the squeeze on everyday people becomes severe. And, those rising gas prices aren't happening in a vacuum.
No, not at all.
They are directly tied to the fragility of the physical supply chain. When you look at the global energy picture in today's brief, our reliance on physical geography becomes glaringly obvious.
It really does. The geopolitical reporting today centers on a highly volatile situation between the United States and Iran.
Right. And just to be clear for you listening, we are just neutrally reporting the facts as laid out in the source material here.
Exactly. Based purely on the latest situation reports detailed in the brief, the U.S. has expanded its military strikes against Iranian missile defense sites. And in response, Iran has launched retaliatory drone and missile strikes targeting regional bases that host American forces.
The ripple effects of this conflict are actively paralyzing global logistics. The central theater of this confrontation is the Strait of Hormuz.
Which is a crucial choke point.
Right. For anyone picturing this on a map, this is a remarkably narrow, shallow waterway sitting between the Persian Gulf and the Gulf of Oman. It is the primary artery for a massive percentage of the world's daily oil supply.
Yes.
And right now, the brief notes that vessel traffic through that strait has dropped by approximately half. 50% of the commercial traffic is just gone.
It's astounding.
Because the insurance premiums and the physical risk of a ship getting caught in the crossfire is simply too high.
And it gets more complicated. Iran is actively treating American intervention in the area as a national red line. And they are expanding the threat matrix beyond just the Persian Gulf.
Right. The brief mentioned Yemen.
Yes. Tehran is urging Houthi forces in Yemen to prepare for action around the Red Sea and the Bab el-Mandeb Strait, which is the vital gateway to the Suez Canal.
So you are looking at multiple critical global shipping arteries facing simultaneous threats. Commercial airlines are entirely avoiding portions of Gulf airspace just to dodge the risk of military drones.
Yeah, the logistics nightmare is everywhere.
And the only reason oil prices haven't completely skyrocketed, though they're still sitting near a one-month high, with Brent crude around $84 and U.S. crude near $79, is because Iraqi oil exports managed a slight rebound.
Right. They're pumping about 1.2 million barrels a day, which offered some slight relief.
But that price floor near $84 a barrel bleeds directly into the inflation we just discussed.
Absolutely. It costs more to fuel the cargo ships, more to run the domestic delivery trucks, and more to manufacture petroleum-based plastics. The geopolitical friction in the Middle East trickles down directly to the retail price of consumer goods in the Midwest.
Here's where it gets really interesting to me. Think about the massive irony here. We started this deep dive talking about embedding microscopic lasers into silicon chips to process artificial intelligence.
Right, pure future tech.
We are practically living in the year 2100 in our data centers. Yet the foundation of that entire advanced economy remains completely tethered to whether a slow-moving cargo ship can safely float through a century-old maritime choke point.
It's a striking contrast.
Our sci-fi future is still powered by 19th century geography.
And if we connect this to the bigger picture, that glaring vulnerability is driving a massive strategic shift in the markets.
How so?
The energy narrative in Thursday's brief isn't just about conflict. It is entirely about the desperate need for diversification. The volatility in the Gulf is the exact catalyst driving historic investments into advanced batteries, alternative energy, and domestic supply chains.
Oh, I see. It connects right back to TSMC building in Arizona.
Exactly. You cannot run a multi-billion-dollar AI data center if your power supply depends on a disrupted shipping lane halfway across the planet.
Right. It's about building resilience against single points of failure.
Precisely. The world is recognizing that these physical dependencies are unacceptable liabilities. We are seeing major traction in alternative baseload power.
Like what?
Well, the brief specifically highlights a resurgence of interest in nuclear power because it provides dependable domestic generation that isn't reliant on global maritime choke points. Governments and corporations are spending hundreds of billions to build overlapping redundant systems because they finally realize how fragile the physical supply chain really is.
And we are seeing that physical fragility tested not just by human conflict, but by the environment itself.
Yeah, that's a whole other layer.
We don't even have to look to the Middle East to see our infrastructure pushed to the breaking point. We are seeing it this very weekend right here in the United States, and it is directly threatening the biggest cultural and sporting event of the year.
The environmental data in the brief is alarming. We are tracking a punishing heat dome entrenched across the Southwest, with desert locations consistently sitting at or above 110 degrees.
Which is just brutal.
It is. And simultaneously, massive plumes of Canadian wildfire smoke have drifted down and blanketed the Northeast, triggering officially unhealthy air quality alerts across New York and New Jersey.
And right in the middle of that unhealthy air in New Jersey is the Sunday World Cup final, taking place at the stadium in East Rutherford.
The timing is incredible.
You have the defending champions, Argentina, looking for a back-to-back title against Spain, who are seeking their first World Cup win since 2010. And adding incredible historical weight to this, it is highly likely to be Lionel Messi's final World Cup match ever.
The stakes for the sport are just monumental. Even on Saturday, you have the third-place match down in Miami, featuring France playing an England team that is still processing a brutal late-game semifinal loss.
But the environmental context makes this deeply concerning. The brief highlights that nearly one-fifth of all the matches in this entire tournament have been played under extreme heat conditions.
Right.
Conditions that players' representatives consider fundamentally dangerous.
And this raises an important question because this is where the disparity of our infrastructure becomes so apparent. We can spend billions of dollars to engineer climate-controlled stadiums, right? We can perfectly regulate the temperature and air quality to protect the 22 elite athletes on the pitch, but we cannot air condition the surrounding environment.
Right. You have 80,000 spectators expected inside that stadium in New Jersey. You have tens of thousands more fans gathering in outdoor fan zones and local venues just to be part of the atmosphere.
Which is a huge public health concern.
Exactly. Local authorities are having to plead with vulnerable populations, the elderly, children, anyone with respiratory issues, to simply stay indoors. They are urging people to limit movement and hydrate because breathing this mixture of extreme heat and wildfire smoke is a genuine health hazard.
It serves as a massive stress test for regional infrastructure. Think about the strain on the local power grid as millions of residents crank their air conditioners to survive the heat and filter the smoke.
Oh, wow. Yeah, looping right back to the grid issues.
Right. And think about the public transportation systems trying to move 80,000 people safely through a toxic heat index, or the emergency health services on standby for heat exhaustion. The physical world is aggressively testing the systems we rely on.
They're basically hoping a cold front and some rain push through before kickoff, just to make the environment survivable. Whether you are a brilliant AI developer coding a new neural network in Arizona or a massive football fan trying to watch Messi's last dance, you simply cannot code your way out of the physical climate.
That perfectly synthesizes the entire reality of today's brief. This sporting event is a microcosm of everything we've discussed. The digital realm does not exist above the physical world. It is entirely subordinate to it.
Let's take a quick step back and look at the intense journey we've taken you on today. We started by digging into the massive, resource-heavy concrete and steel foundations being poured for TSMC's AI factories.
Right.
Then we traced how that physical build-out relies on a divided American workforce, where skilled trades are booming, but everyday consumers are walking a tightrope of inflation and high borrowing costs.
Yeah.
We watched global shipping routes freeze up in the Middle East, proving how tethered our high-tech future still is to physical choke points. And finally, we looked up at the smoke-filled skies over the World Cup final, watching extreme weather stress test our power grids and public health systems in real time.
I mean, it can feel overwhelming to look at all these physical constraints at once.
Definitely.
But there is a remarkably provocative thought buried in the science section of today's source material that reframes this entire dynamic.
Oh, I love a good paradigm shift.
Yeah.
What are we looking at?
Well, we have spent the last 20 minutes talking about how the AI boom is relentlessly devouring physical resources, the water, the electricity, the heavy grid equipment.
Right, the heavy industrial footprint.
But the brief also explicitly notes that these new AI models are radically accelerating analysis across biology, chemistry, and material science. We are seeing physical, automated laboratories directly hooked up to advanced computational models, conducting thousands of experiments a day.
Okay, wait, I see where you're going with this.
Consider this possibility. What if The very AI infrastructure that is currently draining our power grids and consuming our raw materials is the exact technological tool humanity will use to invent the next generation of solutions.
Oh, wow.
These systems could be what finally unlocks commercial fusion energy, discovers radically efficient battery materials to replace fossil fuels, or even engineers new crops that can survive 110-degree heat. We are locked in a high-stakes race between physical consumption and digital innovation.
That is a wild, incredible concept. We're essentially burning our physical resources today,
Yeah.
betting everything that the digital brain we are building will be smart enough to figure out how to save those resources tomorrow.
It's quite a gamble, but it's where we are.
That is a fascinating thought to leave on. So the next time you tap your phone and get an instant answer from the cloud, remember the concrete, the microscopic lasers, the cargo ships, and the power grids making it happen. The digital world is much heavier than you think. Thank you so much for joining us on this deep dive. Keep questioning the world around you, keep looking past the screen, and we will catch you next time.